One common type of question you'll be asked in contests is, how do I figure out how many perfect square divisors are in the number 144? Or say out of the 15 divisors, I pick some random divisor. What is the probability that that divisor is a perfect square? Well, in order to do that, we can find the amount of perfect square divisors by using another type of manipulation. So in our power of 2 to the power 4, there are 3 options we can have, which we can include in our perfect square. Now let's look at why these 3 options work. If you take the square root of 2 to the power 0, you get 1. Square root of 2 squared gives you 2, and square root of 2 to the 4th gives you 4. So therefore, if you take the square root of any of these factors, we will end up with an integer. So therefore, these factors work. Now the reason why a factor of some exponent of odd power does not work is because if we take, for example, the square root of 2, we will end up with some decimal or irrational number, which is not an integer. So therefore, we know that powers of only even numbers will work because those even numbers can easily be divided by 2 through the square root. So here we actually have 3 choices. Now for the 3's, we have 3 squared, meaning that 3 to the power 0 and 3 squared work. Because there are even powers, if we take the square roots, we will get 1 and 3, giving us a total of 2 choices. So now multiplying this, we have 6 total choices for perfect squares. 6 divided by 15, probability of picking a perfect square out of the factors of 144, which if we divide by 3, we find that the probability is 2/5 or 40%. Now another type of problem you'll see is factors with regards to cubes, if they are perfect cubes or perfect powers of 4. Now in order to do this, we can do it similarly. We see that if we want to find the amount of perfect cube divisors of 144, the factors, each individual prime factor has to be a cube. So let's say that we're trying to find the amount of perfect cube factors of 2 to the power 4. Here we will see that there are 2 choices, 2 to the power 0 and 2 cubed. And the reason why is because if we take the cube root of either of these factors, we will end up with an integer. In general, if you take the cube root of some numbers, let's say 2 to the power of 3a, where a is some integer, taking the cube root will leave you with 2 to the power a. So really, we can see a pattern here. If you take the cube root of any number whose exponent is to the power of 3, it will return an integer. Similarly, taking the 4th root of a number that has an exponent that's a multiple of 4 will return an integer, and so on. Because essentially, you're just dividing the exponent by the root you are taking it by. So here, if we're trying to find cube exponents, we will see that 2 to the power 0 and 2 to the power 3 work, giving us 2 choices. If we check 3 squared, we see that the only one is 3 to the power 0, giving us 1 choice. Because 3 to the power 1 and 3 to the power 2 will not return integers when the cube root is taken of them. So in total, we have 2 times 1, which is 2 perfect cube divisors. Now you can also apply this same technique with perfect powers of 4, or 5, or 6, or so on. So this is one of the most important manipulations you'll see in contest problems.